Second example, product mix problem. Formulate the following LPP. A firm manufacturing two types of electric items A and B can make a profit of rupees 20 per unit of A and a profit of rupees 30 per unit of B. Each unit of A requires 3 motors and 4 transformers, and each unit of B requires 2 motors and 4 transformers. The total supply of these per month is restricted to 210 motors and 300 transformers. Type B is an export model requiring a voltage stabilizer which has a supply restricted to 65 units per month. So there is a firm manufacturing two types of items A and B. Given that a firm can make a profit of rupees 20 per unit of A and a profit of rupees 30 per unit of B. Profit per unit of A is 20 rupees and profit per unit of B is 30 rupees. Both of these items require two components. One is motor and another is transformer. Each unit of A requires 3 motors, 4 transformers. 3 motors, 4 transformers. Whereas each unit of B requires 2 motors, 4 transformers. 2 motors and 4 transformers. And it is given that total supply of these, that means total supply of motors and transformers, is restricted to 210 motors and 300 transformers. That is, quantity of motors and transformers available per month is given. How many motors are available? 210 motors. And how many transformers are available? 300 transformers are available. And the last statement is type B is an export model requiring voltage stabilizer and it has a supply restricted to 65 units. So the number of units of item B manufactured in the firm should not be greater than 65. So one more number is given, 65. We now construct a table which contains this data. Let us put all the information in the given problem in this table. A firm is manufacturing two types of product, item A and item B. It is given that a firm can make a profit of rupees 20 per unit of A and a profit of rupees 30 per unit of B. This is the last column, profit per unit. The profit is rupees 20 per unit of A and rupees 30 per unit of B. Next, each unit of A requires 3 motors and 4 transformers. Each unit of A requires 3 motors and 4 transformers. Whereas each unit of B requires 2 motors and 4 transformers. 2 motors and 4 transformers. The total supply of these motors and transformers per month is restricted to 210 motors and 300 transformers. So quantity of motors available per month is 210 motors and quantity of transformers available per month is 300 transformers. And one more number is there, 65. That is, supply of the second type of item is restricted to 65 units. So we will consider this number while constructing the constraints in this LPP. Title of this middle column is requirement of motors and transformers per unit of item A and item B. Suppose that a manufacturer or a company produces X1 units of item A and X2 units of item B. Now in this problem, the objective of the firm is to maximize the profit of the firm. What is the total profit if we produce X1 units of A and X2 units of B? Therefore, total profit of the firm is equal to profit of X1 units of A plus profit of X2 units of B. Now it is given that profit on 1 unit of item A is rupees 20. Therefore, profit on x1 units of item A will be 20 into x1. Profit of 1 unit of A is rupees 20. Therefore, profit of x1 units of A will be 20 into x1. Next, profit of 1 unit of item B is rupees 30, and therefore profit of x2 units will be 30 into x2. Profit of 1 unit of item B is rupees 30. Therefore, profit of x2 units of B will be 30 into x2. So total profit will be 20x1 plus 30x2. Let us denote this sum by Z. We denote objective function by Z. Here Z is the total profit. This is equation number 1. Now let us find total number of motors required if the firm manufacture x1 units of A and x2 units of B. How many motors required? This will be one of the constraint. Similarly, second constraint will be how many transformers will be required if the firm manufacture x1 units of A and x2 units of B. Now, the number of motors required to manufacture x1 units of A and x2 units of B is equal to. Now look at the table. Each item of A requires 3 motors. This is the title of this column. Requirement per unit of A. How many motors require? 3 motors. And a firm manufacturing x1 units of A. So how many motors will be required for x1 units of A? 3 into x1. 3 into x1. Similarly, 1 unit of item B require 2 motors. So x2 units of item B will require 2 into x2 motors. So these are the total number of motors required to manufacture x1 units of item A and x2 units of item B. This total should not be more than 210 because only 210 motors are available per month. Every month 210 motors are available to manufacture these two items. So this total number of motors required to manufacture x1 units of A and x2 units of B, this total should not be greater than 210 because only 210 motors are available. This total, that is total number of motors required to manufacture x1 units of A and x2 units of B, should not be more than 210. Since it is given that only 210 motors are available per month. So therefore, this total 3x1 plus 2x2, it is not greater than 210. It means it is less than or equal to 210. This is the first constraint we have constructed on motors. Similarly, we can construct one more constraint on transformers. Next, the number of transformers required to manufacture x1 units of A and x2 units of B are now look at the column transformers. Each item of A require 4 transformers. Similarly, each item of B require 4 transformers. So x1 units of A will require 4 into x1 transformers and x2 units of B will require 4 into x2 transformers. One unit of A require 4 transformers. So x1 units of A will require 4 into x1 transformers. Similarly, 1 unit of B require 4 transformers. So x2 units of B will require 4 into x2 transformers. But it is given that only 300 transformers are available per month. So this total number of transformers should not be greater than 300 because only 300 transformers are available per month. This total, that is total number of transformers required to manufacture X1 units of A and X2 units of B should not be greater than 300. Since it is given that only 300 transformers are available per month. Therefore, 4x1 plus 4x2, this sum gives the total number of transformers required. This should not be greater than 300. That is, this sum should be less than or equal to 300. This is the constraint on transformers. One more number is given in the LPP. The number is 65. Supply of item B is restricted to this number. Type B is an export model. It requires voltage stabilizer and its supply is restricted to 65 units per month. And we are manufacturing how many units of B? We are manufacturing X2 units of B. So X2 should not be greater than 65. Therefore, we write X2 less than or equal to 65. This is the third constraint. Also, it is given that supply of item B is restricted to 65 units. And a firm is manufacturing X2 units of B. Therefore, X2 should be less than or equal to 65. It should not be greater than 65. So this is the third constraint in this LPP on the second item. And in every problem, non-negativity constraints are always there. So finally we write x1 comma x2, both quantities are non-negative quantities. We are manufacturing x1 units of A, this number cannot be negative. We are manufacturing x2 units of B, so this number cannot be negative. So both are non-negative values. Thus, we have to maximize the profit of the firm using the available resources, that is, using the available quantity of motors and transformers. Hence, the LPP is maximize the profit Z represent the total profit of the firm 20x1 plus 30x2. So maximize this sum 20x1 plus 30x2 subject to following conditions. These conditions are called constraints of the problem. So what is the first constraint? Equation number 2. Total number of motors should not be greater than 210. 3x1 plus 2x2 should not be greater than 210. So we write 3x1 plus 2x2 less than or equal to 210. Second constraint is on transformers. Total number of transformers should not be greater than 300 because only 300 transformers are available. 4x1 plus 4x2 should not be greater than 300. So this sum should be less than or equal to 300. 4x1 plus 4x2 less than or equal to 300. This is the constraint on transformers. One more constraint is there. X2 less than or equal to 65. Number of units of item B produced or manufactured in the firm should not be greater than 65. So we write X2 less than or equal to 65. These are the three constraints of this LPP. And non-negativity constraints are always there in every LPP. So we write x1 comma x2 greater than or equal to 0. So this is the required LPP.